Hi there. This brief lesson will show you how to use the tonets to understand triadic transformations. Let's go ahead and get started. This is a tonets, which is the German word for network of tones. It's in some ways like a circle of fifths, that it shows a tonal space, but instead of showing us a relationship between keys, it's showing us a relationship here between triads. And I won't go into the history and background of why it was developed or the theories behind it. I just want to look at it practically and show you how to use a tonets to describe various triadic transformations. Let's start by trying to figure out how the tonets is laid out. First of all, you'll notice moving along the horizontal axis from left to right, you see an ascending perfect fifth relationship. Moving down this axis, you'll see minor thirds, and then moving on this axis, you'll see all major thirds. These three axes create a set of triangles in the network, and if you'll look closely, you'll notice that all of the blue triangles, those that are pointing up, are all minor triads, such as this ACE, A minor triad. And all of the red triangles in the network that are pointing down are major triads, such as the A C sharp E triangle that's right below it. Now, if I flip this A minor triad along that bottom axis, it becomes an A major triad. And that flip can also be reversed from A major to A minor. So a flip along the horizontal axis goes between parallel triads, A major and A minor. So we call this the P transformation for parallel. Now if I take that same minor triad and flip it along its right axis, it becomes CEG, or the C major triad, and then flip it back over and it becomes A minor. And you'll recognize that relationship between triads as the relative relationship. So we call this the R transformation. I can sort of see that those two triangles are leaning towards the right. That's another way of remembering the relative or R transformation. Now there's one more side to this triangle, so if we were to flip it across the left axis, it becomes the F major triad, and then vice versa, it flips back from F major to A minor. Now, unlike parallel and relative, we don't have a name for this relationship. The theorist named Hugo Riemann called it the Leichttonwechsel, or leading tone exchange transformation, and it's represented by the L, so it's an L transformation. And you can sort of see that the triangles look like they're leaning towards the left. So that's one way of remembering the difference between L and R. R sort of looks like it's leaning to the right, and L looks like it's leaning towards the left. And then the P relationship is the parallel. Those are the three main triadic transformations. There are some other transformations that are a bit more complex because they require multiple flips. One of the most common of these is the slide transformation, because it requires an L, P, and an R, and together that is the S transformation, or the slide transformation. You'll notice that it doesn't flip across the side. It connects at one of the points, sort of like a bow tie there. Now, if you were to do an R, L, and a P, then that's what we will call an N transformation, or a near fifth, which is another bow tie kind of transformation. The last of these bow tie transformations is the PRL, which we then call an F transformation, or far fifth, as opposed to the near fifth. Another transformation that has been given a special name is an LPL, which moves it to what we call the hexatonic pole, and you can see that it's moving it's moving steadily in one direction. Now let's see how these transformations would look on the staff, starting with the parallel transformation. Notice that you will keep the perfect fifth in this chord. Those are the two common tones. And then the middle, the third, will move by half step between C major and C minor in this case. And then back. In the relative transformation, there will also be two common tones. In this case, it's the major third, and then the remaining voice moves by a whole step. So in this case, from C major to A minor, sounding like this. Now, if I had started with a minor chord in root position, then I would still keep the major third common tones and the remaining voice would move by a whole step. It just looks a little different. And there's still a relative relationship between E flat major, the second chord, and C minor, the first chord. The last transformation here, the L transformation, I keep two common tones. In this case, I keep the minor third, and the remaining voice moves by a half step. It's called the leading tone exchange because the root is exchanged for the leading tone there. I think that's where the name comes from. Now, if I had started with a minor triad in root position, I would still keep the minor third common tones and move the remaining voice by half step as well. In the triadic transformations we've looked at so far, only one of the notes has needed to change, so the voice leading is very smooth. Now with these other triadic transformations, remember there are more flips on the tonettes, so the voice leading is not quite as smooth. The slide transformation keeps one note the same, and then the root and the fifth move by half steps like this. This is the near fifth transformation. With two voices moving by half step. The far fifth transformation. With two voices moving as well. Now, the hexatonic transformation has all three voices moving, and this is one of the most distant transformations. Essentially two chromatic medians there. Okay, that's basically it for this short introduction to triadic transformations, or also known as Neo-Riemannian theory.